Stan Gibilisco here to describe the concept of zero bias in regards to the operation of a transistor or vacuum tube, either a bipolar transistor, a field effect transistor, or a vacuum tube. So, instead of hanging around the giant gaseous cavity within star-forming region NGC 3324, courtesy of HubbleSite.org, let's just go right to the circuit and show you an example with an NPN bipolar transistor. The one on the right here, is operating at zero bias. By zero bias, all we mean is that the emitter, or the control electrode, is at the same DC potential as the emitter, or basic electrode that serves as the ground usually for the DC part of the system. In the case of a field effect transistor, this would be the source and this would be the gate. In the case of a vacuum tube, this would be the cathode and this would be the control grid. But zero bias simply means that the bias voltage between this electrode here and this electrode here is zero. They are at the same potential. Note that there's a coil here, but that is a DC short circuit. Not necessarily for AC, but zero bias applies to direct current only. Every device, be it a bipolar transistor, a field effect transistor, or a vacuum tube, has its own particular and unique behavior when you apply zero bias to it. Some are designed to operate that way normally. Others are not. It all depends on the type of the device and on the particular model number of the device that you want to use. Zero bias is an important concept in amplifiers at all frequencies, from audio all the way through microwaves. Stan Gibilisco, retiring back to the gaseous cavity nebula, where things might be a little bit easier to think about, but certainly a lot less useful in electricity theory and electronics theory. Until next time, have a good time, have a good sleep, learn a lot, and so long for now.